children, taking quickly two more questions. See, the fourth one, it says in an AP, the pth term is 1 by q and the qth term is 1 by p. Now, using these two conditions, you have to prove that sum of first pq terms is half of pq plus 1. And over here, p is not equal to q. So, we can assume that the first term of AP is a and the common difference is d, so that these two terms can be written in terms of a and d. Now the first condition says the pth term is 1 over q. That means Tp is equal to 1 over q, and using the formula for general term, Tp can be written as a plus p minus 1 into d, which is equal to 1 over q. In the same way, qth term is 1 over p. So Tq is equal to 1 over p. That means Tq can be written as a plus q minus 1 into d, which is equal to 1 over p. So this is first equation in terms of a and d. This is second equation in terms of a and d. And if we subtract both of them, then a and a will get cancelled out. So subtracting 1 and 2, a and a gets cancelled out. And the second term will be this minus this. Can you see they both have got d as a common factor? So if I subtract them, taking d common, we get p minus 1 minus q minus 1. Okay, and on the right side it becomes 1 over q minus 1 over p. We'll simplify this to get the value of d. If I open the bracket here, you will see plus 1 and minus 1 gets cancelled out. And we are left with p minus q into d. On the right side, if we take LCM, it is p minus q divided by pq. What next? You can see p minus q on both the sides can be cancelled out, and d is 1 over pq. Now, once the value of d is obtained, you can either put it in first equation or in the second one to get the value of a. So, here I have substituted it in first equation. What do we get? A plus p minus 1 into d, which is 1 over pq, is equal to 1 over q. Now, shifting this entire term to the right side, a will be 1 over q minus p minus 1 over pq. So, this part needs to be simplified. We can take LCM here. You will see LCM is pq. So, this one needs to be multiplied with p. So, a is equal to p minus this term. If I open the bracket, it will be minus p plus 1. So, a is p minus p plus 1 over pq. Plus p and minus p gets cancelled out, and a is 1 over pq. So, what do you see? Both a and d, they are 1 over pq. Because first term and common difference are known, so we are ready to write the sum of whatever number of terms we have to find. Over here, we need sum of pq terms. So, n here is pq. So, you replace in the formula for sum of n terms, you replace n by pq. So, sum of pq terms will be pq over 2 into twice of a plus pq minus 1 into d. Put the value of a and that of d. We get pq over 2 multiplied with, this is twice of a. So, it becomes 2 over pq plus pq minus 1 divided by pq. So, what do you find? Within the bracket you see in both the terms pq is the common denominator. So, we can add the numerators straight away. So, if we take LCM here, sum of pq terms reduces to pq over 2. Then within the bracket, the sum of the numerator comes out to be 2 plus pq minus 1 whole divided by pq. So, you can see pq and pq we can cancel out. 2 minus 1 will become plus 1. So, the ratio comes out to be pq plus 1 over 2. This is the sum of pq terms as required. You can see. Then one last one quickly. It says if the sum of n terms of an AP is of this form, where p and q are constants, find the common difference. See, even these type of you have done in class 10th, it can be done in two ways, either by replacing n by its values 1, 2, 3 and so on, or you can even write that the nth term can be written as, see, this is also a formula. An can be written as Sn minus Sn minus 1. So, once we get the last term, nth term, all the terms can be evaluated. Okay, let us go for a simpler version. Sum of n terms is given to us. If I replace n by 1, then how many terms are included in the sum? It is only the one term. So sum of 1 terms means the first term only. So first what we will do? We will replace n by 1. So you can either write it S1 or you can write it A1 also. So it is P into 1 plus Q into square of 1. So what do we find? The first term is coming P plus Q. Now if I replace n by 2, it will denote sum of first two terms. So S2 means first term plus second term. Now S2 can also be obtained by replacing n by 2 here. So if I replace n by 2 here, same you can do here also. So S2 can be written as P into 2 plus Q into square of 2. And on the right side, we have written it as A1 plus A2, where A1 is also known to us. It is P plus Q. So P plus Q into P plus Q plus A2. Fine. So do the necessary simplification. If I shift this to the left, we'll get A2. It is twice of P plus 4Q, then minus P minus Q. So 2P minus P is P, 4Q minus Q is 3Q. So see, A2 is also known to us now, and common difference we can define it as second term minus first term. Put the value of A2 as well as A1, and you see P in both gets cancelled out, and we get 3Q minus Q, which is twice of Q. So the common difference for this is 2Q.